I'm going to do high school maths. It's going to be aimed at ages kind of like 13 to 17. And if you find, it's going to be about solving quadratics. And if you find quadratics easy, then you might find the beginning easier and then the end harder. And if you find quadratics really hard, then you might make the most use of the beginning, and then maybe the end you'll find a bit harder. But don't worry, just like try and do what you can. And as we go, you can throw as many questions into the chat as you want. And if you're like, whoa, I need that explaining more, then just say that as well, and I will slow things down, or vice versa. If you want things sped up, say that too, and I will see what I can do. Thanks all for coming. Let's get started. I'm going to start on this, I think, first. This has absolutely nothing to do with quadratics, but I just wanted to start with it because I was reading about it this morning. This is a box jellyfish. Now, has anyone ever had any dealings with a box jellyfish? Does anyone know anything about box jellyfish? Box jellyfish are not very nice. But anyway, here's your box jellyfish to start things off. So the question I want to know to begin with, again, this has nothing to do with quadratics, but it's just something for fun while we wait for everyone to join. Box jellyfish. What is this? Who knows what this is? And also, who knows what's bad about box jellyfish? Lina was saying they've got really powerful jelly, and also that he knows nothing about quadratics. That's fine that you don't know anything about quadratics. The whole point is that I'm going to talk you through it. Okay, so no, this is not a sea... Well, you're right, it is a seashell, but it is also a scallop, or a scallop, or a scallop. I don't know how people pronounce this, but anyway, it's a food that you can eat near the seaside, and it's super delicious, but it doesn't stay fresh for very long. Anyway, so, and the reason why box jellyfish, I asked if anyone knows anything about them that's kind of negative. The sting of box jellyfish is one of the most painful stings in the world, if you get stung by one of these. I once got, well, I say once, it was only a few months ago, I had all these stingers like wrapped around my entire body, but thankfully it was from a much less deadly and painful jellyfish than the box jellyfish. But the stings from these things can even be fatal. They are extremely painful, and if you see photographs of people's skin, like people's skin literally gets burnt away sometimes. And Ali Stone is saying that it's nice with cheese and gratin, which I guess is referring to the scallop rather than the fatal sting of the box jellyfish. Although, to be honest, everything is pretty good with cheese and gratin, so yeah. Leonardo's saying there's an antidote. Yeah, that's right. So very recently, there's been a few antidotes developed to box jellyfish. There's one being developed in Australia that if you apply it within 15 minutes of being stung, you can get rid of almost all the pain and hopefully, well, not die from it. And there's also been another one that's been developed in Hawaii for their local kind of box jellyfish that stops all your red blood cells, which are the ones that carry all the oxygen around your blood. Stop those from rupturing, because the sting can like basically rupture your red blood cells as well if you get the wrong kind of box jellyfish. There are several kinds of box jellyfish. And not all of them are as bad as the others, but anyway, they're pretty bad. Now, I was the reason I've given you verses, and again, if you are just joining and you're wondering what this has to do with quadratics, the answer is nothing. We haven't got to the quadratics bit yet, but we will get there. The thing I wanted to ask you guys first is, how many eyes does a box jellyfish have, and how many eyes does a scallop, I'll say it. How many eyes do each of them have? So what do you guys think? Let's have a box for the number of eyes for a box jellyfish here, and we'll have a box for the number of eyes that scallops have here. And I want you to say what you think. How many eyes do they have? So this is an eye off, in effect. Just a healthy little eye off. Box jellyfish as well are often described as being quite fish-like because they actively swim like around obstacles, and they actively swim towards their prey as well. So they're particularly dangerous in that if they see you and they want to sting you, then they will swim very rapidly towards you, unlike a lot of jellyfish that kind of float around in much more of a passive way. Box jellyfish are pretty good swimmers when they wiggle their little wiggly swimmy things. Okay, so maybe 2 eyes for the box jellyfish and 1 eye for the scallop. Anyone else got any guesses? I'm going to throw in the actual numbers. So box jellyfish have 24 eyes each. 24. They don't have very sophisticated brains, but they've got a ton of eyes. And I was saying, I know scallops have loads, but don't know how many. So scallops have up to 100 eyes. So scallops win this one. Nice work, scallops. You deserved it. And yeah, that is true. I'm just seeing on the chat. Yeah, the turtles do eat jellyfish. So one of the big problems with plastic pollution in the ocean is that a lot of plastic pollution looks a lot like jellyfish, and that's one of the reasons that turtles go for it and try and eat it, and that's one of the big problems with the plastic pollution. Anyway, right, that's enough of box jellyfish versus scallops, which was a fun thing to begin with, but ultimately has nothing to do with quadratics, and as I promised, I'm going to teach you guys about how quadratics work. So, first thing we're going to start with is, what is a quadratic? So, I wonder if anyone knows what a quadratic is. If you do, throw it into the chat. I'm keen to know what people already know. And meanwhile, I'm going to start explaining it. So in maths, you often get bits of algebra written out. Like you might get something like this. 3x plus 7 equals 5. And that's a bit of algebra. Now, a quadratic is just a piece of algebra that has a term in it. And when I say a term, I'm talking about these different bits that you plus together. So this is one term, this is another term, and this is another term. So to be a quadratic, all it has to have is an x squared term in it. So if we have x squared, then it's a quadratic. Now, when you're looking at different bits of algebra, this you call a quadratic because it's got an x squared. This, so if we have 4x cubed plus 7 minus 2x squared. We don't need to solve this. I'm just giving you an example of how you name these things. Now this one, the highest power of x is 3. So this is x cubed. And so we call this one a cubic. So this one would be a cubic equation, and this one we call, because it's got x squared as the highest power, we call that a quadratic. So quadratics are just equations that you have to solve that have x squared in them and nothing higher like an x cubed or an x to the 4 or an x to the 5 or something like that. So that's what a quadratic is. Okay, and I just saw Leonardo ask, what does x mean? So in maths, x stands for the thing that we don't know yet. So it partly comes from Arabic, and then it's something to do with, I've forgotten this story, but it's something to do with the Arabic language converting to Spanish and then people not quite being able to pronounce something, and it was some other symbol before that was used for the unknown thing that we're trying to discover, which has ultimately become x. So x just means the thing that we don't know yet. So this is a quadratic equation because we've got x squared. This is a cubic equation because we've got x cubed. I'll go one higher, but you just won't see these very often at all in your maths. But x to the 4 minus 3x squared plus 5 equals 7, something like this. That's x to the power 4, and so you would call that a quartic. So basically, quadratic is just a fancy name, like a really fancy name for saying we're solving an equation that has x squared in it. And that's it. Okay, cool. So that's what a quadratic is. Now, before we go on to solving quadratics, I wanted to go over here and just talk to you for a bit about expanding brackets. So if I wanted you guys to do this, see if you can answer this for me in the chat. If I wanted you to do x plus 3 squared, then what do you think the answer will be? X plus 3 squared, what answer does that give? And if you are joining late, I'll just say one more quick welcome to anyone who's joining late. Thanks for coming to this Aim High Live. Today we are doing high school maths, and this is aimed at kind of ages like 13 to 17ish, and we're doing solving quadratics. And quadratics are a kind of equation that has x squared in them, which becomes one of the most important equations that you solve throughout all the times at school. And when you go into anything, if you go into anything to do with science or engineering, or even just like trying to work out basic problems at home, often like quadratics come into it. They're one of the most important parts of maths, which is why I was learning a whole lesson on them. Okay, so Alistair and Karina have both got this spot on. Oh, I just saw that someone commented that there was a lot of buffering. Is that true? This is something I can possibly solve if so. I think the buffering seems to be fine on my end now, but I'm sorry if it was buffering a bit before. Okay, so Alistair and Karina are both spot on. Right, so the thing that people will often do wrong here is they will think, well, it's going to be x squared plus 3 squared, which is x squared plus 9. But actually, that is not the full answer. So to get the full answer, sometimes it's easier to write it out, as it looks like some of you have already done really well, as x plus 3 times x plus 3, because that's what squared means. It means something times by itself. So we're doing x plus 3 times x plus 3, and when you multiply these brackets out, you have to times the x here by both things in the other bracket. So we're going to times it by x, and we're going to times it by 3. And same with this 3 here, we're going to times it by this x, and we're going to times it by this 3. Now, often people will organise this with a word called FOIL. Now, those of you who already know how to do this, we're going to go into the harder things in a mo, like completing the square and quadratic formula, but just so that we can cover everything, I'm just going to quickly explain to people how to do this. So often this is referred to as FOIL because this number, this and this, are both the first things in each bracket. So that's F. This and this are the outer terms, so the terms on the outside. So we label them as O for outer. These two are the inner terms, so the two terms on the inside. So we label those as I for inner. And then these two are the last terms, and so we label them as L. So often this is referred to as FOIL. And FOIL is the kind of checklist that it's quite useful to go through to make sure that you've multiplied everything by everything else. So multiply the first terms together, multiply the outer terms together, the inner ones and the last terms. Now to quickly show you what this means. So the first terms, x times x, is going to give you x squared. So that's our first. X times x is x squared. And then our outer is going to be 3 times x, so plus 3x. And then our inner is going to be 3 times x, so plus 3x again. And then our last is going to be 3 times 3, which is plus 9, which means that we get the result that lots of people were saying, which is x squared plus 6x plus 9. Great. Okay, cool. So let's have a quick check to see if everyone followed that with something quite similar. So can you guys try expanding this and tell me what you get? So let's do, we're going to do 2 actually. We're going to do x plus 3 times x minus 1. What does that give? So try and race me to work it out and throw your answers in when you get them, because I'm going to go through it quite slowly. So for those who haven't still got it quite yet, let's do the first ones times together first. So first, if you want, we can list it out like this, FOIL. So first is x times x, which is x squared. And then let's do our outers. So the outer 2 is going to be minus 1 times x. Remember, the sign in maths always belongs to the thing to its right. So this is a minus 1. The minus does not belong to the x, the minus belongs to the 1. So this is minus 1. Minus 1 times x, so that's going to give us minus 1x or minus x. And then we can do the inners. So that's going to be 3 times x equals 3x. And then our last numbers are 3 and minus 1. So that's going to be equals minus 3. So when you add all of these together, it's going to be, let's line them all up. So x squared. So plus 3x minus x is going to give us plus 2x. And then we've got minus 3 at the end. So x squared plus 2x minus 3. Cool. Right, great. Okay, now let's try a harder one because that seems pretty good. And Leonardo, by the way, perhaps you're reading the X as a times sign because I'm wondering how it is that you're getting the answers that you're getting. But I hope that you're starting to follow the things that we're doing. If you are younger than 13, and I feel like you might be younger than 13 because I remember you being on another one, then this will be quite tricky because you haven't done some of the other algebra that will help you solve this stuff. But great if you can manage to do some of this, but don't worry too much if you can't. Okay, so let's try expanding this one. So 2x, this one's going to be quite a bit harder. 2x plus 7, and then multiplied by 3x minus 4. Now, while people are starting to do that, I just wanted to very quickly, just partway through the lesson, just stop and say, we are really keen to, as Aim High, to like chat to some of the students, maybe some parents, maybe some teachers, and like try and find out how we can do this even better. And so rather than just asking you guys to fill out surveys, if you're up for chatting to us about how we can make this better, then sometime after the lesson, email this address, team@aimhigh.co, and say you're up for doing an interview with us, and we'll schedule a chat. So that it'll probably be with me and someone else. I think it'll be Marianne. But we are really keen to chat to people to find out how we can make this as good as possible. So do email us on there if you're up for chatting to us about how you found Aim High and how you think it can be better, and any of your ideas would be so valuable. So do jot that down somewhere if you're up for chatting to us. Anyway, there it is, team@aimhigh.co. Anyway, right, so back to this. Let's see, I'm going to run through it really quickly, and it looks like people are already putting in answers, which is great. So the first times together is going to give you 2x times 3x, which is going to be 6x squared. 2 times 3 is 6, x times x is x squared. And then our outer is going to be 2x times minus 4, which is going to be minus 8x. And then our inner is going to be 7 times 3x, which is going to be plus 21x. And then finally, our last is going to be 7 times minus 4, which is going to be minus 28, which gives us 6x squared. And then we can put these two terms in the middle together because they're both x. Remember, this is a really important thing to note, is that you can't mix x squared terms with x terms, but you can mix the x terms together. So if we're adding 21x and we're minusing 8x, then that is the same as adding 13x. Oh, let's just get black. And then we can minus 28 at the end, and that is great, perfect. Okay. Cool. I just wanted to point out one other thing here, which you may or may not have noticed, which is the way that helped me to learn how to do first, outer, inner, last, which is that this looks like a smiley face, right? Smile on the bottom, and then eyebrows on the top. anyway, that was one of the ways that helped me to learn how to expand brackets when I was first doing it. But yeah, so great those who can expand. Leonardo, I'm noticing that you're still finding this quite tricky. And don't worry, because we will do another lesson in the future where we do simpler maths, starting with what is algebra. And also, I think I did a bit on algebra the other day. But it feels like there are a few things in between this lesson that we're doing now and the things that you know. And so I'm going to keep going with like solving quadratics and going through all the different methods for all the other people on the stream, because I think that that's what I promised to do, to talk about solving quadratics. But I hope you'll come back for one of the other ones that you'll have done the kind of maths that you need to have done before for. Okay, so let's go to, but also like, well done for being on the stream. Super brave to like throw yourself into solving quadratics if you haven't done much algebra before, because this is one of the harder bits of algebra. Okay, so factorizing, why and how does this work? So so this is the kind of problem that you might get of a quadratic. You might get, let me just get rid of this scallop, much as I love scallops as characters on the board. Okay, so factorizing, why and how do we do this? Yeah, this is the kind of question that you might get in a book, which, to begin with, maths questions are weird in that often, you know, like, you're just doing them and you don't really know why you're doing them, but ultimately, like, they end up becoming the basis for solving actually really interesting real world problems. But you always have to just learn how to do them first before people kind of let you loose on real world problems. So anyway, yeah, x squared plus 3x plus 2 equals 0. So this is the kind of thing that you might have to solve, and they might say to you, can you find out what x is? What is x in this? Now, first thing to do is the reverse process of what we were doing below. So below, we were taking brackets and we were multiplying them out to give this. And now we want to go in the other direction. So I want to turn this into a set of brackets. So who can do this already? Equals 0. So Karina has already said exactly the right answer. Yes, perfect. Okay, so let's quickly work through how this works. So how are we going to get x squared? We're going to get x squared by having an x at the beginning and an x at the beginning here, because then when we times these two together, that's going to give us our x squared. Now, next thing to consider is how are we going to get our 2? So I often at this stage will kind of like look at the 2 and be like, well, the ways that you can get 2 are, well, the only way you can get it is 1 times 2. So it has to be 1 times 2. And that's really all you can do. So I would then put a 1 and a 2 here, because when you multiply these two together at the end, that'll give you your plus 2. Now the question is, what symbols do you need to put here? Do you need to put minuses or pluses? Minuses or pluses here in order to get plus 3x when you combine these things. So here you have to do a bit of thinking ahead and think, okay, 1 times x, that's going to be 1x. 2 times x, that's going to be 2x. So 2x and 1x, if we add them together, we're going to get 3x. And so we want both of these to be plus signs. So x plus 1 times x plus 2 is going to give us 0. So great. This is the key point that we wanted to arrive to. And this is something, I don't know who figured this out, but whoever did it must have been like, this is such a genius brainwave, because it is kind of amazingly clever that they've done this. Right, here's the question. I'm going to kind of go over here for a little bit and ask you, what number has to go in this space? So let's say you've got 16 and I want you to times by a number so that we get 0 as the answer. What does this number have to be? And similar question again. If we have 5 and we're going to times by a number, then what does that number have to be so that we get 0? What number goes here? What's the only number that works there? Exactly, 0. It has to be 0. The only number that can times by something else and make 0 is 0. No other number can possibly go in that space. So what you're being asked to do here with quadratics is, if this orange blob, and I'm just going to treat them as blobs for a moment, if this orange blob is going to multiply by this green blob, and together they're going to make 0, then that means if orange times green equals 0, that means that, and I'm sorry if fact these are probably not the best colours to have used if you might be colourblind, so let me just put a black ring around the orange one. So if you're this orange blob in a black ring and you're timesing by the green blob, then the only way for this to equal 0 is if either the orange blob in a black ring or the green blob equals 0. So either this must be 0 or this must be 0, because you're going to multiply them together and make 0. So that's the key idea behind factorising quadratics and why it works, is that either this has to be 0 or this has to be 0. So to get the final answer, all you do is you say, well, x plus 1 has to equal 0, or x plus 2 has to equal 0. And then you can solve both of these really easily by this one, by minusing 1 from both sides. So we get the answers that Karina has already put in, which are x equals -1 or -2. And I say or because both will work. And this is one of the really key things to look out for with quadratics when you start solving them, like we've just done for the first time now, is that when you solve quadratics, you will get 2 answers almost every time. There are some cases where you'll get 2 answers, but they'll be the same answer, and therefore you'll kind of have only got 1 answer. But ultimately, you should always be looking for 2 answers, because there are two things that can work, -1 or -2. And if you sub these in here, you'll find that it works. -1 squared is 1, -1 times 3 is -3, and then +2. So 2 add 1 is 3, -3 is 0. And it'll work if you sub in -2 as well. Cool, so that is why quadratics work, because when you multiply one thing by the other thing, one of them has to be 0, so you set them both equal to 0, and that's how you get your answers. Now, let me give you guys another problem to try and solve. Try this one. So I want you to try x squared plus 2x minus 8 equals 0. And Alistair, that's such a good summary of why that works. Yes, brilliant. Okay, so let's see who can do this. Again, let's try factorising it. So x squared plus 2x minus 8. And if you are one of the people who's joined very late, then thanks for coming. This is an Aim High Live, so we're going through high school maths today. We're doing solving quadratics, making it easy to do factorisation. We're about to do the quadratic formula and completing the square. So if you've ever been like wondering how those work or why those work, then we're just about to cover those. We're just doing a quick check. We're just doing a quick check of factorisation and how it works. So let's see who can solve this. X squared plus 2x minus 8, and I'm just going to go through how this works again. So first things first, let's put out some brackets that we're going to try and put it into. Karina's answer is so fast. So x squared, that means we're going to have an x at the front and an x at the front here, because when you multiply them together, you'll get x squared. Now, in order to get minus 8, we've got different options. So we could either have 1 times 8, ignore the minus sign for now, or you can have 2 times 4. So now you've got options. You need to think, are we going to put a 1 and an 8 here? Or are we going to put a 2 and a 4? And you have to decide by basically a trial and error, by going through each one. So let's try with a 1 and an 8. So this would give you 1x and 8x. Is there any way of adding or minusing them to get 2x? So 1x, 8x, no. So that can't work. So let's get rid of those and try 2 and 4 instead. So can this work? 2 times x and 4 times x, so that's 2x and 4x. Is there any way of combining 2x and 4x to make 2x? So if you've got 4x and you've got 2x, how can you make 2x? And the answer is you can by minusing them. So you need to make sure you're going to have minus 2x and plus 4x. So if we put a minus sign here, that'll give us minus 2x, and if we put a plus sign here, that'll give us plus 4x. So that works. X minus 2 and x plus 4 equals 0. That works out. I'd love to be able to do more practice of these, but these lessons are all quite short to cover quite a lot of stuff. But in the future, I'll do much slower versions of each of these for those who are struggling. And I'll also do higher level ones for those who are finding this easy. So, yes, x minus 2 and x plus 4 equals 0. Which means that either this or this has to equal 0. So if x minus 2 is 0, then x has to be 2, right? Because 2 minus 2 is 0. So one of the answers is that x could be 2. And the other answer here is that x could be minus 4, because if x is minus 4 plus 4 is 0. So that would make this bracket 0. So those are your two possible answers. X is 2 or minus 4. Which is great. I think you all got that. Great, brilliant. Okay, let's do one more practice of this, and I'm going to do a much harder one to challenge those who found that a bit easier. So can you try and solve this? And this is the last one, and then we'll go on to our quadratic formula and completing the square. So 2x squared plus 9x equals 18. So who can solve that? 2x squared plus 9x equals 18. So I'm going to go through this as well, but do please race me if you want to do it faster. So the first thing to do is make this equal 0, because like you just saw before, that's how we solve the quadratics. We make them equal 0 so that we can do something times something equals 0, and then we know that each of the things could be 0. So first let's do that by minusing 18 from both sides. So 2x squared plus 9x minus 18 equals 0. 2x squared plus 9x minus 18 equals 0. So now when we make our brackets, it's a bit harder because we need to find something that multiplies together to give 2x squared to begin with. So the only way that's going to work is if you have an x here, and think about what's going to go here. It's going to be a 2x, because 2x times x gives you 2x squared. 2x squared. Okay, so next we need to think what numbers multiply to give 18. And we've got a bit of a long list here, which is annoying. So we've got 1 and 18 can go together, or 2 and 9 can go together, or 3 and 6 can go together. And so we've actually got quite a lot of options to go through. We've got 1 and 18, 2 and 9, 3 and 6. And the only way of solving this is by putting each of those in one by one and trying to see which one works. So if we put in 1 and 18, then this is going to be 36x, and this is going to be 1x. Can you combine 36x and x by adding and minusing them to make 9x? No, so that isn't going to work. So let's get rid of that, and then we can try it the other way around. So let's try 18 here and 1 here. So if we have 18x, and this is going to make, what do you think? This is going to make 2x. So if you've got 18x and 2x, can you add or minus them to make 9x? Again, no. So we can't use 18 and 1. So we abandon that as our strategy, and now we try 2 and 9. So let's try 9 and 2. So if you have 9x and 4x, can you use those to combine them to make 9x by adding or minusing them? Again, nope. So we ditch those as a suggestion, and we can try it the other way around, 2 and 9. So 2x and 18x, again, can't add or minus them to make 9x, so we have to reject that as well. Let's try it this way around, 3 and 6. So if we've got, this is going to give us 3x, and this is going to give us 12x. Can we combine those by adding or minusing them to make 9x? And the answer is yes. 12x take away 3x will give us our 9x. So we need to make sure we've got minus 3x and plus 12x. So think about what symbols are going to go in each of these spaces. Are we going to put a plus or a minus here? Or are we going to put a plus or a minus here? What do you think? So because we want plus 12x and minus 3x, we're going to want a minus here, so we get minus 3x, and we're going to want a plus here, so we get plus 12x. So plus 12x minus 3x, and that gives us our 9x. So this is going to give us our answer. 2x minus 3 and x plus 6 equals 0. I know that was quite long, and that's why often people will use these other methods like the formula that I'm about to go to, and because sometimes they can be quicker. But yeah, so if x plus 6 equals 0, then that's one of your options, and that implies that x equals minus 6. And if 2x minus 3 is 0, then this one might be a bit harder to work out, but if you add 3 to both sides, then that will give you 2x equals 3, and therefore x equals 3 over 2, or 1.5. So overall x can be minus 6 or 3 over 2. And those are your two answers. So that was quite a harder solving by factorization, but that's how you do it with some of the harder quadratics. Right, okay, so who got that right? That was a bit of a harder one, I think. I think that one was quite a bit harder. So I'm keen to know if you'd like to do another one. I mean, we're kind of running out of time, but I could maybe do another one of those at the end, if people want to do one. But anyway, now I'm keen to go over to the quadratic formula. So the quadratic formula is this, yes, the quadratic formula is this really super slick way of solving any quadratic problem without having to worry about factorizing it or anything else. You can put it straight into your calculator and it'll just spit out the answers for you. And it's kind of like a piece of magic that does loads of the work for you. And it works like this. So let's say you've got a problem like this. We're actually going to do one that's similarly hard to the one we just did. So let's start with and show you how you can solve it really easily with the formula. So if we've got 2x squared minus 13x plus 21 equals 0, then sometimes people write this out like this. So x squared x and then equals 0. I'm kind of leaving gaps here, but you'll see why in a mo. So people write it as this: ax squared plus bx plus c. So if you look at this top formula here, 2x squared minus 13x plus 21 equals 0, then when we're doing quadratic maths, we label the number that you're timesing by x squared as a. So that number is a. I know this looks a bit like a z, but it's supposed to be a 2. It's just my pad didn't work too well. But anyway, the number that we're timesing by x squared we label with a. The number that we are timesing by x we label with b. So b is going to be minus 13. Because remember, the minus sign always belongs to the thing to its right. So b is minus 13. And c is 21. So with any quadratic, you can find out what a is, what b is, and what c is by just lining it up like this. ax squared plus bx plus c. So really quickly, just to practice to make sure you're following, if I gave you this, let's do 13x minus 2x squared plus 7 equals 0. Then what is a and what is b and what is c? A equals, b equals, c equals. Let me know what you think. 13x minus 2x squared plus 7 equals 0. What is a, what is b, and what is c? So remember, a is the number that you're timesing by x squared, b is the number you're timesing by x, and c is the other number that you're not timesing by anything. It's called the constant, and that's actually why it's conveniently been given a letter c. C is often used in maths to represent just a number by itself. Okay, I'm going to start filling some of these in because I haven't seen answers coming in yet for this. So a is going to be the number you're timesing x squared by. So a is going to be your minus 2. B is the number you're timesing x by, so it's going to be 13. And c is the other number, so that's going to be 7. It's often easier if you write it out in this order: ax squared plus bx plus c. Right, okay, just a quick check over that to make sure you understand. So a is the number you're timesing x squared by, minus 2. B is the number you're timesing x by, 13. C is the number that's by itself. Now, once you've got this, and once you've laid it out and crucially made it equal to 0, so important that when you're solving quadratics, you make them equal to 0. Oh, I just saw that Karina put in the right answers there, so I'm wondering if perhaps there's just a long delay. So yes, well done, that's spot on. So yes, crucial that you make it equal to 0, and then you can solve it in this way. You can solve it by writing, and don't think you have to remember this because this is super long as a formula and it'll be written down for you. But x, so the answer that you're looking for, is always equal to minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now, this seems really complicated, but it's just something that you can type into your calculator. You might be wondering, if you haven't seen this before, what is this plus minus? What does that mean? And what it means is plus or minus. So you'll first type it into your calculator with a plus, and then you'll type it in with a minus to get your 2 different answers. So let's pop that over there. And for this thing that we're trying to solve, minus b, so b we know is minus 13, so minus b is going to be 13. And then we're going to plus or minus afterwards. And then the square root of, now b squared, this is the place where almost everyone types this in wrong on their calculators, and this is where all the problems come from. So when you're typing this into your calculator, if you're doing it on a calculator, make sure you put the thing you're squaring in brackets, because if you're squaring minus 13 and you don't put it in brackets, then your calculator will just square the 13 and then put a minus in front of it, and that's not right. You need to square all of minus 13. Another rule of thumb is that when you square a number, you always get a positive number. So 13 squared is 169. So let's write that straight in instead of writing this. So 13 squared is going to give us 169. And then we've got to do minus 4 times a times c. So it's minus 4 times 2 times 21. So that's going to be 42, 164, so minus 164. I think that's right. Wait, let me just recheck that. Oh no, it's minus 168. Sorry, I'm off. So that's going to be minus 168. Cool. Okay, so then we can divide through by 2 times a. So now we're going to divide by 2 times a, and a is 2, so we're going to be dividing by 4. So if we now move this up a little bit so that we can write underneath it. Let's move all this up. Make a bit more space. So this is going to be equal to 13 plus or minus 169 minus 168 is 1. The square root of 1 is 1. So this is just 13 plus or minus 1 over 4. So if you do 13 add 1 and then divide by 4, then that's going to give you 3.5. And if you do 13 minus 1 and divide by 4, that's going to give you 3. So there you go, those are your 2 answers straight out of the quadratic formula. Let's see if anyone else got the same thing. So Karina said 14 and 4 or 3, perfect. And Anastone also got exactly the right answer for how to work the formula. Perfect, yes. The key idea is just make sure you square all of b, because that's the classic thing that people do wrong, is they square 13 and then they put a minus sign in front of it. That's where the disasters creep in. Right, okay, let's do the last bit. I want to show you guys how to complete the square. So completing the square is a bit of a weird way of solving quadratics, which I think is actually the best way. I'm going to just get rid of all this stuff. So completing the square is, in my opinion, the most beautiful way of solving quadratics. And when I say beautiful, it's like you get, when you do quite a bit of maths, you start to get a feel for like stuff that is just really clever, the way it works out and the way it really simplifies the problem for you. Completing the square is probably the easiest way of solving quadratics if you can get the hang of it. So let's show you how it works. It works like this. If you've got a problem like x squared plus 2x equals 15, then what's the first thing you have to do? What's the first thing you have to do to this in order to solve it as a quadratic? Have a think. And now I'll tell you, I just want you to think about it. The first thing you need to do is set it equal to 0. Make it equal 0. So x squared plus 2x minus 15 equals 0. So we minus 15 from both sides. And that's how we're going to make this work. Now, I'm just going to get rid of this top line because we do not need it anymore. So if this is the problem we're trying to solve by completing the square, then we do it like this. So first, we just look at this bit here. And I'm going to ignore the rest of the whole thing. Wait for that siren to go by. So I'm going to ignore the rest of the whole thing. I'm just going to look at this bit here. So x squared plus 2x is kind of like this. It's kind of like x plus 1 squared. Now, the reason why I say that is because x plus 1 squared is x plus 1 times x plus 1. And if we do that with FOIL, so we do the first numbers times together, so first times first is x squared. And then outer times outer, x times 1 is plus x. Inner times inner is plus x again. And last times last is 1 times 1 is plus 1. So therefore, x plus 1 squared is the same as x squared plus 2x plus 1. So, if we just look at this bit, notice how x plus 1 squared is exactly the same as what we started with. So x squared plus 2x at the beginning. Now, obviously, it's got a different end to the other one, but the beginning is exactly the same. And it's really easy to find this, because all you have to do is take this number and half it, and then put it into this form. So x plus 1 squared, x squared plus 2x, use half this number to give you x plus 1 squared. Right, now, because you know that x plus 1 squared is the same as this, but plus 1, what we can do is just minus 1 from it, and then we have got rid of this extra plus 1. So if we now, let's take this down here, if we simply write after this minus 1, then we now know for sure that this is exactly the same as this. I'm just going to take you through why that works one more time. So x squared plus 2x, we're saying it's almost the same as x plus 1 squared. And we found that just by halving this number. Now, if you expand x plus 1 squared, then you get x squared plus 2x plus 1, which is the same as x squared plus 2x, but then we just need to minus 1 to make it exactly the same. So let's now get rid of those circles. So now that we're happy that those two bits are the same, we can now finish this line as if it's the same as the line above by just writing, now we're going to write minus 15, and then we're going to write equals 0. So x plus 1 squared minus 1 minus 15 equals 0. So we know for sure that these two bits are exactly the same as one another. because what we did is we took a square and then we completed it. So this is the square that forms almost that, and then we completed the square with this number. And then we finished the equation. So who can solve this and give me an answer? Karina's already got an answer, which looks great. And so has Alistair. That's perfect too. So x plus 1 squared minus 16 equals 0 is the same as equals 16. So remember, when you're doing quadratics, very, very important to take the positive and negative square root, because you should always be looking for two answers when you do a quadratic. So x plus 1 equals plus or minus the square root of 16. And so you can rearrange this to give you... So square root of 16 is 4, so it's plus or minus 4, and then we have to minus 1 from both sides. So x equals plus or minus 4, and then minus 1, which equals 3 or minus 5. Spot on, you guys who got that right. That was really, really good. Okay, cool. Let's try it one more time, and then we will finish. So the last one that I want you to try is this. Have a go at x squared minus 6x minus 16 equals 0. So try racing me to do that. I'm going to do it quite slowly for anyone who's not following. So what we do first is we do x minus 3 squared. So that's the square that we found just by taking this bit here, halving this number, and we know that when we expand that, it's going to give us x squared minus 6x, and then because of the minus 3 times minus 3, it's going to give us plus 9. So now we need to minus 9 from this to complete the square, so that we get rid of this plus 9. So that's why we minus 9 there. So x minus 3 squared minus 9, and then we're going to carry on the equation. So minus 16 equals 0. And then you can solve this by doing x minus 3 squared, and then minus 9 minus 16 is going to be minus 25 equals 0. So if we add 25 to both sides, that's going to give us x minus 3 squared equals 25. And then we can square root both sides. So that's going to become x minus 3 equals, and then square root of 25 is 5, but we want plus or minus 5, because minus 5 and plus 5 both square to give 25. So x equals 3 plus or minus 5, which gives us 8 or minus 2, which you've both got, although Ali, your one was slightly wrong because it's got to be minus 2, but almost perfect. Great, okay, that was great. Thanks so much for coming, everyone. I hope that that was helpful and made sense. And yeah, as I said before, if you want to get involved with chatting to us about how we can make this better in like a face-to-face chat, and we'd really like that. Don't have to if you don't want to, but if you want to, then please email team@aimhigh.co, TEAM, team@aimhigh.co, and tell us that you're keen to get involved. That would be great. Otherwise, do please sign up for our schedule if you haven't already. Do follow our socials and do spread the word. And thanks so much for coming. And Karina, I'm really glad you learned something new. What were the new things that you learned? I'd be really keen to know. I am gonna say goodbye now, but I'll just hang around on the chat because I'm keen to know what extra stuff you learned and why this was useful. So yeah, thanks all for coming. I will be back in... Oh, when am I back? I'm back pretty soon. I'm going to be back in 1 hour to do vectors. So, and also, I think that just before me, so... Oh, no, I'm the last one for today, and then there are 3 more tomorrow. So check out the website above if you haven't already to find out what's going on tomorrow, and I will see you guys in an hour. Fairly well. Bye.